Hello friends, welcome to UGC EPG Pathshala. I am Dr. Dilip Kumar, Assistant Professor in Geography, Shahid Bhagat Singh Evening College, University of Delhi, New Delhi. The current session is on runoff estimate from watershed and hydrological modeling. Under this session, we will discuss on factor affecting runoff and method of runoff estimation. The simple meaning of runoff is the flow of precipitated surface water toward river, pond and ocean. In another word, runoff is a movement of water to a channelized stream after it has reached the ground as precipitation. The movement can occur either on the below the surface and at different velocity. The surface runoff is a portion of water that flow over the surface and reach the river, pond and ocean during precipitation. Initially, rainwater to emerge into the ground until the soil became saturated. After the soil saturated, the excess water on the surface to flow into nearby low-lying area in the watershed. This excess water that flowing over the land is known as surface runoff. See the figure number 1. The estimation of the runoff is required for the management of the soil and water resource by suggesting the conservation structure such as flood, forecasting, water balance studies, environmental impact assessment and engineering planning like dams, spillway and outlet or any waterway. Generally, runoff occurs only when the rate of precipitation, that is intensity, exceeds the rate of infiltration. Once the infiltration rate is exceeded, water begins to fill the surface depression, which called surface or depression storage. After the depression are filled, water flowing over the land as overland flow. Runoff is the portion of rainfall which moves down to the stream, channel, river or ocean as surface or subsurface flow. Overland flow is the water which run across the surface of the land before reaching the stream. In the subsurface through flow, some author refer to this as lateral flow, occurs in the shallow subsurface predominantly, although not always in the unsaturated zone. Groundwater flow is in the deeper saturated zone. All these are runoff mechanisms that contribute to stream flow. The runoff modeling is very much applied to the decision making in the hydrological system and their problems such as flood, contamination study, etc. Rainfall runoff modeling can be carried out within a pure analytical framework based on observation, input and output to a catchment area. The catchment is treated as a black box without any reference to the internal processes that control the rainfall to runoff transformation. Information on runoff and sediment yield could provide light on the degradation of watershed and thus identify critical source area for starting development program. The factor affecting the rainfall. Number 1 is physiography. It includes the shape and size of the watershed, slope, drainage pattern and density. The shape of the watershed determined at the time of concentration. Long and narrow watershed have long time of concentration resulting lower runoff than circular or square watershed because it take long time to leave watershed and more opportunity to water to soak into the soil. The size of the watershed determines the runoff volume and rate. As the watershed size increases, runoff volume and rate increases. However, runoff volume and rate per unit of watershed area decreases as the area increases. So, watershed size and area determines the peak rate of runoff, which is the important parameter for designing erosion structures. The slope of the watershed determines the velocity and extent of the runoff water. There is positive correlation between land slope and velocity. As greater the slope, greater the velocity. According to the Galileo's law of falling body, distance traveled by a falling body is directly proportional to the square of the time it takes to fall. Hence, if the watershed slope is increased 4 times, the velocity of the water flowing on the slope is doubled, resulting cutting capacity or erosive power is increased 4 times, as well as carrying capacity of the water increased about 32 times, and size of particle that can be transported by rolling or pushing is increased by 64 times. The drainage pattern is a design of stream course and their tributary, which is influenced by structure, lithology and slope. Dendritic pattern has fine drainage texture, indicates the impervious rocks formation and low permeability. Here the soil is deep, heavy and slow permeable, prone to severe to very severe soil erosion, forming gully due to high runoff. The radial, braided and pinnate drainage pattern associated with the medium drainage texture. The rocks are characterized by joints and fractures. Soil are moderately deep, medium soil texture and moderately permeable, subject to moderate to severe soil erosion. The coarse drainage texture of the trellis, rectangular and annular drainage pattern generally associated with shallow and coarse soil texture, resulting high hydraulic conductivity, where water can move through pore and fracture very easily. It relatively less prone to the soil erosion. The drainage density also influences the runoff pattern. Higher the drainage density, increase the runoff water very rapidly, decrease the lag time and increase the peak of hydrograph. Soil and geology. The soil and geological characteristics determine the amount of siltation in the water harvesting structure such as dam and reservoir, as well as amount of water percolated in the soil. Precipitation. The amount and nature of precipitation is the most important factor which determine the runoff in a watershed. The quantity and rate of runoff. The quantity and the rate of runoff is prerequisite for the planning and designing of canal, ditches or any other water harvesting structure to store the runoff. The volumetric assessment of water is most important while impounding or creating reservoir. The rate of runoff is essential for conveying water from one place to the another place by creating mechanical fracture to accommodate the flow of water. Theoretically, watershed with impervious rocks and no loss of water, maximum rate of runoff would be directly proportional to the rate of rainfall. So, more the rainfall, more runoff. But in the natural condition, there are various interceptors such as vegetation, infiltration into the soil, stored in depression, and some rainfall is evaporated. Therefore, estimation of rate of surface runoff depends on the rate of runoff and the water available for runoff. The time of concentration. When the rainfall occurs, the water takes time to reach the outlet. Thus, time taken for water is traveled by overland flow from one point of watershed to the outlet is known as time of concentration. There are various factors that affecting the concentration time such as size, shape and slope. The larger the watershed will take more time to concentration of the water and vice versa. The shape of the watershed is determined by the shape factor, which is defined as a ratio of basin area to the square of basin length. The value of form factor would always be less than 0.7854. The smaller the value of form factor, more elongated will be the basin. The basin with high form factor have high peak flow of the shorter duration, whereas elongated Watershed with low form factor have low peak flow of low duration. If the basin size is same, flood flow in such elongated basin are easier to manage than those of the circular basin. The slope of the drainage basin increases the slope as the time of concentration is very less. Intensity, duration and frequency of rainfall. The relationship between these three components of rainfall is very important while planning for various rain harvesting structure. The intensity and duration of the rainfall has inverse relationship. Higher the intensity of the storm, lower the duration of rainfall and vice versa. The most severe rainfall lasts for shorter time and the storm that lasts for longer duration give the more total amount of rainfall that give impact on runoff. Hydrologic condition of the soil. The hydrologic condition of the soil is determined by the moisture content at the time of the storm. Soil with humus, organic content and temperature increase the capacity of moisture content, resulting volume of runoff and vice versa. Vegetation cover. The canopy cover of the vegetation act as interceptor and create barrier along the flow of water, reduce peak discharge. So, the type of quality of vegetation on land influence the runoff, infiltration rate, erosion and sediment production and the rate of evaporation. The foliage and its litter maintain the impact of rainfall and increase the potential of infiltration to the soil and the soil protect soil erosion. Thus, the canopy cover and the ground litter create barrier to the water to flow on the land surface, resulting increased time of concentration and it reduce the peak discharge rate. The land use, land cover and conservation practices. The land in the drainage basin consists of the various natural cover and different uses by the human beings such as forest, agriculture, built up area, etc., affecting the rate of runoff and infiltration. Forest and agriculture act as inceptor and increase the infiltration, but built up area accelerate runoff and reduce the infiltration of runoff, infiltration of rainwater to ground. The conservation practice reduces the volume of runoff as well as the soil erosion. Contouring and terracing conservation method reduces the sheet erosion of the soil and increases the amount of rainfall withheld from the small reservoir. The method of runoff estimation. There are various methods for the runoff estimation which is suitable for the small watershed such as rational method, curve number method, Cook method, table method and the hydrograph. For applying these methods, two assumptions are made. One is rainfall occur with uniform intensity over the entire drainage basin, and secondly, rainfall occurs at uniform intensity for duration at least equal to the time of concentration of the drainage basin. Number 1, the rational method. This method is widely used for the estimation of peak rate of discharge from a small watershed due to its simplicity and easy application. Developed by Kuliching for small drainage basin in urban areas. This method relates runoff producing potential of the watershed, the average intensity of rainfall for a particular length if time and the watershed drainage area. It is expressed by the equation. When catchment area with different value of C, the weighted value of C should be calculated for the whole watershed. The storm intensity is a function of geographic location and design exceedance frequency. It is true that longer the return interval, greater the rainfall intensity for a given storm duration. Also, longer the length of the storm, lower the storm average rainfall intensity. Though rational method is simple, but it also has some limitation. There is a hardly over a rain completely satisfied both the assumption of uniform intensity for at least the duration of the time of concentration and over the entire area of the watershed. This method is applied to very small watershed with an area less than 1300 hectare. The value of the runoff coefficient is based on the study on a broad range of topography, soil and land use condition, but a small watershed are mostly affected by land use, tillage and cropping pattern, as well as the effect of different conservation and agronomical practices that should be considered for estimation of coefficient. In spite of limitation, this method is considered accurate for estimating runoff for relatively inexpensive water harvesting structures. Another method is Cook method. The Cook method is developed by an engineer of the United States Soil Conservation Services. This method is considered most suitable for watershed up to the 400 hectare. The runoff characteristics of a watershed is examined under the 4 category of relief, soil infiltration, vegetation cover and surface storage. The approximate weightage is obtained from table 2. The peak runoff is obtained by the runoff curve and the drainage area for 10 years. The peak runoff value is modified by multiplying with the rainfall frequency and shape factor. The another method is the curve number. This method is based on the recharge capacity of watershed, which is determined by antecedent moisture condition and by the physical characteristics of watershed. This method is most rational and realistic method, determine both peak rate and volume of runoff for small watershed by synthesizing information about the soil cover, physiographic feature and flow characteristics. This method is also known as hydrologic soil cover complex number method. A combination of a specified soil and a specific cover is referred to as a soil cover complex, and a measurement of this complex is used in this method in estimating peak rate. It is calculated by the following formula, where Q is accumulated storm runoff in mm, P is the accumulated storm rainfall in mm, and S is the potential maximum retention of water by the soil. To simplify the above equation, empirical relationship between the variable S and IA was developed from the data collected from the various watershed in USA, resulting the following equation. For AMC1, IA is equal to 0.3S, AMC2, IA is equal to 0.2S, and IMC3, IA is equal to 0.1S. For Indian condition, Central Soil and Water Conservation Research Training Institute, Dehradun has suggested IA is equal to 0.1S for the black soil region, AMC 2 and 3, IA is equal to 0.3S for soil region AMC 1, and IA is equal to 0.3S for all other region. There are 3 basic data is required for this method. Number 1, antecedent moisture condition, which is the index of soil condition with respect to runoff potential before storm, and it has 3 categories. You can see the table number 3. The second is hydrologic soil group, known as HSG. It can be categorized into the 4 groups on the basis of intake of water on bare soil when thoroughly wetted. Refer the table 4. The land use, land cover data with their hydrologic condition as mentioned in table 5. Let us see an example. Given a 8.122 hectare farm with an average slope 0.9%, with watershed is under straight row crop and falls under the hydrologic soil group B. 2 years rainfall of 24 hours, duration is 95.25 mm. Compute the runoff depth in mm. The solution is Curve number for given land use and hydrologic soil group B is 86. Refer the table number 5. Now to find the peak runoff, that is 55.3 mm for the watershed by using the above formula. The next method of runoff estimation is the table method. There are wide variation in the annual rainfall amount from low rainfall to serve storm, and the difference in runoff and mostly influenced by variation in the surface condition, then the variation in the rainfall intensity. A single set of table can be used for determining the peak rate of runoff through the country. The high rate of runoff is influenced by the shape of the watershed, such as square, long and narrow. So the separate table are used for determining the runoff from the watershed up to 500 acre. Refer the table number 6, 7 and 8. The field investigation of the watershed for the determination of its characteristics such as vegetation cover, slope and soil type. For that, refer table number 9. See the example. A 30-acre square watershed of bare soil of fair, permeable and depth with a moderate slope has a sum of watershed characteristics of 60, that is 25 plus 25 plus 10 is equal to 60. The peak rate of runoff is 76 cubic feet per second. The hydrograph. The hydrograph provides the rate of flow or peak flow at the portion in the time during and after storm or snow melt event, because a hydrograph plot volumetric flow rate against time. Integration of the area beneath a hydrograph between 2 points in time given the total volume of water passing the point of interest during the time interval. The hydrograph in figure 2 shows two graphs. One is rainfall measurement in mm and another is water discharge in measured in cubic meter per second from watershed. The highest rainfall is a graph shown in a peak rain and highest discharge of the peak discharge. There are two limbs in discharge graph. One is the rising limb, another is the falling limb. The time between the highest rainfall and the highest discharge is known as a lag time. Thus, in addition to peak flow, hydrograph allow analysis of size of reservoir, storage tanks, detection of ponds and other facilities that deals with volume of runoff. The application of runoff estimation in hydrologic modeling. Beside other factor, runoff estimation is most important for the planning of reservoir. The capacity of the irrigation canal, installed capacity of powerhouses will depend on the available supply of water. The hydrological investigation are required to give detailed information about the runoff pattern at a proposed project site. To determine the storage capacity of reservoir, determination of hydrograph of a flood is important to determine the spillway capacity and design. Runoff potential map is important for the construction of rainwater harvesting structure such as farm pond, percolation tank and groundwater recharge. The Thorvent and the Mathers model can be used for calculating the surface runoff potential zone by using rainfall, temperature, soil, land use and vegetation. Hydrological modeling can be used for watershed conservation planning. Watershed is an area from which runoff resulting from precipitation flow past a single point into large river, lake or ocean. Each watershed is an independent hydrological unit and modification reflects on the runoff pattern and sediment yield of watershed. The protection of watershed implies the proper use of all land and water resources for optimum production and minimum hazard to natural resources. The main objective is to manage the watershed or to control damage runoff such as flood and utilize for useful purpose such as enhance the groundwater storage. Thank you.